today we're going to talk about Swing. Swing, it's actually not too much, it's just another package. So let's take a look here. Your next programming assignment is to use some Swing components, and you are going to create a Notepad assignment. And I'm not going to go through Notepad today, I'm going to do that on Monday. But today I'm going to go through the basic concepts of Swing, AWT, what they are, how they fit together, how to use them, and then we'll create some programs. Actually, I've got them written for you, and I'll show you where to get them from. They use buttons and images and text boxes and labels and stuff, and basically show you how to do some GUI development. And you think, oh no, GUI development's really complicated. It's actually pretty simple. There's one package. Actually, there's two packages, but there's one package to be primarily focused on. That's what I keep calling Swing. And just like all of the collections came from the collection package, all of the GUI stuff comes from Swing. Why did I call it Swing? I don't know. There's probably an explanation for that. I know what AWT stands for, Abstract Window Toolkit. And that was the original graphic library package that was used. And then along came Swing. It's like, what are we going to swing from a tree? I don't know, swing. So just take it for that. One of these days I'll go look up the meaning, or you guys, one of you guys can look it up for me, and then Monday tell me what Swing actually stands for. I'm sure it's an acronym for something. But anyway, classes from the package Java X. X I know, X Windows. X from windowing package. It's kind of a Linux kind of thing. .swing defines various GUI components. It's not the end-all of end-all. There's also java.awt, and we'll look at that again as well today. Well, we haven't looked at it yet, so I'll show it to you today. So the GUI components come from Java X Swing, and these are the objects what the user interacts with via the mouse, sometimes referred to as event-driven programming. We've already seen event-driven programming because we can put a something out there, and when the user types in something can happen. Which is sort of event-driven. It's kind of like the command line interface. Put a message out on the screen and then say, hey, and then do a system out and then do an in and kind of grab the I/O from that point of view. But GUI is essentially the most event-driven of all in terms of components. So some basic GUI components that we're looking at is JLabel. Okay, so here's how you know the components. You don't go through and memorize all the different components that exist. Instead, you go, well, label. Label would be what? Label. Oh, how about JLabel? And know that every one of these things starts with a J for Java. So if you take the J away, it looks like any other name of any other type of GUI that you'd find in any other program, like Visual Studio or something, So it's kind of standard. These are very similar to HTML, actually, as well, in terms of labeling. So the JLabel is what you might think puts a message out on the screen, non-editable, no box around it normally by default. It's just a piece of some text that appears on the screen in terms of a label. Then we have the text field. That's where you have the box. We can make it a certain length. It's kind of like HTML if you're familiar with that. You can type stuff in there. Checkbox, very combo box. I'm not going to go through all of them because I'm going to assume you haven't crawled out from under a rock. You've used programs. Pretty standard. The list, the panel you may not be familiar with. In fact, the component of the window and the frame is probably going to be new to you as well, especially if you don't have a Java background. Most of the Swing components are written completely in Java, so they have a greater portability and flexibility than the original GUI components that were written in the package of java.awt. So a long time ago when people created Java, the first version of the Java didn't have this thing called Swing. Instead they had AWT. AWT was a package written primarily in C++ actually, or C. Not Java based. In fact, it was somebody's way of adding to the language to give it a GUI, abstract window toolkit, and it was basically primarily focused towards the target platform. Which is kind of weird if you think about Java, because Java is supposed to be cross-platform compatible. You write one Java program and you run it on several different JVMs on the Mac, on the Windows, and all runs the same. AWT didn't quite have that 100%, had some of it, but not 100%. So it used, as an example, the MFC, Microsoft Foundation class. If you've ever done any .NET or Windows programming, MFC is the name of the window interface. gets the library that's produced, or the package that's produced by Microsoft to allow you to create windows and drop-down menus and all of the different GUI components. Well, Mac has a COCA interface. They call it COCA instead of MFC. And you have different things for that. You have a whole entirely different COCA type of environment. If you've ever played around with Xcode, you can see that there's a whole GUI toolkit, drag and drop, and a bunch of other stuff that you can do to create applications that work on a COCA interface, which is what the iPhone works on actually as well. But in terms of Java, someone came around and said, well, what about Swing? What about, or actually they didn't call it Swing in the beginning, but what about creating a Java-enabled package that works on top of AWT in some cases, that implements Windows and implements things, and then that's how we got programs that look like Java. If you've ever noticed Java programs, they all have a distinct kind of Java look to them. To some aspect, you know, they look like Java programs, and you know, the window comes up and it doesn't look like a Microsoft window, but it's running on Microsoft. You know, it's because it's using a Swing component, not an AWT component. So we can talk about the differences between those as we go through the lecture. AWT components are platform dependent. So the AWT component for Windows is the one for Windows. So you can't really write cross-platform compatible programs unless you're using some generic terms like window. COCA's got a window, MFC's got a window, everyone's got a window, X Windows has got windows. So some of the components work, some of them are kind of not going to work if you have to rewrite the application. So some Swing components are still platform dependent actually. JFrame is one of them. So if you write it for one platform, you're going to get the JFrame as an example is going to give you the frame. And I'm going to talk about frames in a few minutes as well as panels. But here's kind of the hierarchy of how it works. For the purposes of this course, we're actually going to be using both, by the way. You know, we'll see in an example, I'll be importing AWT and we'll also be importing Swing. And up until now, everything you've done has been cross-platform compatible. Now, there's a few different quirks you'll get between different platforms when you start creating GUI applications. And I can get you up and running and creating a GUI application in one lecture today. So we'll see how that works. It's not as hard as you think. So here's some common super classes of many of the Swing components. So everybody comes from Java. Everybody comes from Java. Then we have AWT component. Well, because AWT, the Abstract Window Toolkit, is still the component that's generating the GUI for us. So that's still this next level down, and it's the component level. And the component level is going to have the containers inside of them. And the containers are going to, now we're on the Swing. Inside of the container, we have the J components. And the J components from the Swing library are these guys right here. These are the J components. So think of it like a hierarchy in which we have a text box inside of a window, inside of a frame, inside of, it's an object that's running. So we have a hierarchy, and I'll show you the hierarchy, and we'll look at it in a programming example because this is going to make absolutely no sense until you see it implemented to see how it works. But here's a brief definition, and I'll kind of go through half of the PowerPoint, then I'll switch to the programming examples. The component class is the operation common to most GUI components that are found in the component class. That's this class here. Container, one step up. See, components are easy to understand. It's all those J labels, J text box. Those are all the components. The container, there's two important methods that originated in this particular level. It's the container level. We have the add method that adds things to containers. And then we have the set layout. So the add adds a component to a container. Set layout enables a program to specify the layout manager that helps a container position the size of its components. Essentially, layouts in terms of setting definitions like relative layout. Actually, the same thing we get in the Android, actually. The linear layout, the relative layout. The Android interface is actually built on a foundation of Swing, if you think of the concept, actually, because we have the layout, and then inside of the layout, we put the big old container, and we put stuff inside of the container, and we nest it graphically through an XML interface. In Java, without using the Android SDK, we're doing it manually by just putting them in, by creating these things and then adding things to certain things. So the label. So what I'm going to do is kind of go through the components and work up through the hierarchy and give you the foundational stuff, and then we'll look at some examples. We'll see how it's done programmatically. So what we have is the JLabel. JLabel is the object. Provides a read-only text. You can't type it in. As remember before, you just put the words on the screen. Some example code I'll show you in a few minutes. One thing is to emphasize is that you do not explicitly add a GUI component to a container. The GUI component will not be displayed. If you don't put it in there, it's not going to be displayed. You have to explicitly add it, implicitly add it. So the GUI component will not be displayed when the container appears on the screen. If you don't put it in there, it's not going to show up. So you can create a bunch of items, labels, text boxes and stuff, but until you add them to the container, they're not in the container, is what the point, that bullet point's trying to say. So to make an interactive GUI program, to make the interactive program, you're going to need components. Or components. Examples of those would be buttons, windows, menus. Those are all pieces that you're going to fit together. Events. We have mouse clicked, window closed, button clicked, stuff like that. Event listeners, which are interfaces, and event handlers, which are methods. And for those of you who are taking the Android class, we've been covering these so far. So if you've taken that class or you're taking it concurrently, all the same stuff actually. It's all the same, which is great. It's all Java. So, but I'm going to go ahead and review through it for non-Android applications so you can kind of see how it works. The event listener, so the events happen, and events happen whether or not you have a listener or not. If the person clicks on a mouse, takes the mouse and clicks on a button, that event occurs. If you want to capture it, you have to go and implement an event listener. So you set a listener on a button to say, listen to that button. When that user clicks the button, do this, which is what the event listener's job is to do. So it listens for events to be triggered and then performs actions to handle the events once they occur. So in terms of our event handling model, some GUIs are event driven. They generate events when the user actually interacts with the GUI. Not all GUI items are event driven. As an example, a menu is an on menu. Well, it's an, not a menu, like a label is a, click the label, there's no event. But you can actually create your own event listeners to go on a label click or something, or an image click or something. Menus have their own set of event listeners because you need not only the menu but the sub-item on the menu and the item on the menu. And some interfaces that are built on top of this do things in terms of, and if going back to the Android example, we have event handlers that are basic to Java, and then we have the API for the Android interface that builds classes, extends classes from the base Swing classes and creates hand and thumb, hand essential touches, long touches, short touches, swipes to the left, swipes to the right, all of the different things you might find in an application for a handheld device. So it's more touch control versus mouse click control. So in fact, you actually have both. You have mouse click controls on the Android as well because it's built on Java, so it's there. So you can actually write a program that would run on a computer, stick it on an Android phone, hook up a keyboard and a mouse and use it. I'll probably put it on a tablet if you're going to do that, but yeah, like a word processor or something. So it's a kind of an interesting experiment that you could play around with, but you'll find it works because it's in the hierarchy. So here we go back to the concept of event-driven behavior. Moving the mouse, we have the mouse over, and we'll show you that. I'll show you an example of that. Clicking a button, typing in a text field, selecting an item from a menu. Those are all events. When the user interaction occurs, the event is sent to the program. Many event types are defined in the Java AWT events. And then we also have .swing.events, which is built on top of AWT.events. You can actually use both levels. They're both in the same hierarchy. You're just going down to a primitive level when you do the AWT. The Swing components only work, the Swing events only work on Swing components. So you're going to find an instance in which you're using an AWT component, and so you have to use the AWT event that works with the component. Because if you're using a Swing, you can actually use both, but you're going to go to the Swing route for the event. So some event classes are in the package AWT event. Here are the ones that are in AWT event. We've got action event, container event, focus event, key event, mouse event. These are just things associated with a key. and or a text event, item event. And so here's an event-driven model. That's probably not going to make as much sense to you until you see it programmatically, but we have three different parts to the event handling mechanism. The first part is the event source, then we have the event object, and then we have the event listener. So the source is going to be, in a computer sense, a mouse, a keyboard. So it's going to be the GUI component which the user interacts with using the mouse or the keyboard, essentially. Event object is the encapsulated information about the occurred event. Oh, they pressed the mouse long. They double-clicked. They single-clicked. They moved it. They pressed and moved. They did something to it. And then the event listener is an object which is notified by the event source when an event occurs and provides a response to the event. So it's kind of like a try and catch from last lecture, actually, for exception handling. It's done in kind of similar fashion. So a programmer has to perform two tasks to process the GUI event. Register an event listener, which is going to be from one of the packages that we have here. So an event of a class that implements one or more of the event listener interfaces from awt.event or swing.event. And then implement a handler method. So we have a method that's going to be implemented to handle the event when the object of the event is actually registered when it occurs. And here's kind of the layout of the hierarchy. So inside of the event listener interface of the package, we've got lang.object, and inside we have event listener. And then in the event listener, these are all the different types of event listeners. We have action listener, adjust listener, component listener, container listener. Because the person could be clicking on the component from a component level. They could be clicking on the container, the window, the window to minimize and maximize, the component to go away, to come back, to move to the left, to move to the right. All sorts of different things that might be registered. Window listener, text listener, person types in text, mouse over listener, things of that nature. And I'll show you some examples of listeners as well. And then we have a couple of different components. One of them is called the JText field. The other one is the JPassword field. And in here there are single line areas in which, it's like people talking in the hall, single line areas in which the text can be entered in by the keyboard, or the text can simply be displayed on the screen. So when the user types data from them, it passes through the enter key. Maybe we should shut that door, actually. Seems to be, oh, I'm sorry. I didn't mean for you to do it, but I was going to have the TA do it, but I don't know where the TA went. Oh, there you are. Okay, that's okay. That's all right. He was sitting closer. All right. So when a person enters the enter key, and that's automatically given for you. So a lot of the actions and the activities automatically generated for you. The programming part of it is just making an instance of the object and attaching it to a component to say, hey, listen for this event. Buttons. Actually, go back to the text for a second. The text field, text word, the activity could be on the enter, which is the default behavior. We can also put an activity to listen to when the text changes. So somebody could be typing in one box as an example, and then another box could be populated after each key press, which is also possible. So it doesn't necessarily have to occur when the enter key gets hit. It depends on the type of listener that you've attached to the GUI that's going to give you that. Buttons. Buttons are popular. Everyone puts buttons on everything. A button is a component that the user clicks on to trigger a specific action. We can put images on buttons, text on buttons, hover over a button. I don't know, you can do whatever you want with buttons. Several different types of buttons that exist, and they are subclassed. They are all subclassed of abstract button. So we have an abstract button, and we can create a sophisticated button or a basic button. And I've got an example that's going to show you how to create some buttons from the abstract class. We have command buttons, which is created with the J button. It generates an action event. Toggle buttons, check boxes, radio buttons. These are all actually coming from the same hierarchy of buttons. So radio box, check box is actually a button because it's something you're clicking on. And you have an on-click event that occurs with that, which is the action event, the lower level method that's going to occur on the action event. So toggles on and off are a true or false value that's generated, and then a group of buttons might generate from an item event. clicked on a series of 5 radio buttons or something. Excuse me, checkboxes. So radio buttons themselves, a group of buttons in which only one can be selected. It generates an item, same event, item event, item event. But checkboxes is a group, 1 or 2, 3. You can customize the behavior. Radio is usually one of the selection, and then when that was selected, the other one goes off. But you can make radios act like checks and back and forth, actually. Here's a picture of the hierarchy, where we have the J radio button, the J text button that comes from the toggle button, which comes from the abstract button. And then we also have the regular button that comes from the abstract button. And then all of them come from J components, which is that lower level, lower end of the hierarchy. So here are some examples to look at in terms of, and this is a different example that I'm going to show you in a few minutes. But here we have a J combo box, and the J combo box is a drop-down list that provides a list of items. When you click on the item, it generates an item event. So item event's generated. So it's the component. We've got an image here. We've got toggle box. And these images, however, these screenshots come from the Deedle and Deedle textbook that I mentioned at the beginning of the course, actually. Highly recommended, actually, because you'll see a bunch of pictures with a bunch of events and a bunch of GUI components in that book. I'm not going to give you the encyclopedia of swing. You're going to have some reference to go look up to see, well, what do you call those buttons? What do you call that? To find out what this J component is that you're looking at. In fact, there's too many J components, so. Well, maybe a couple dozen, not too many, but no one's going to sit there and memorize them. So this is an example of the J combo box. Here's an example of the J list. It's a multiple selection list or a single selection list with a copy. And these are common characteristics of most GUI programs, to provide this stuff. So, the item event happens on radio buttons, checkbox buttons, combo buttons, boxes, and stuff like that. The list selected event, which is kind of similar, but instead of item, you're on a list. So all of the list components from JList, multiple selection lists, single selection lists, all those drop-down list box are going to trigger different events. Still going to be treated in a very similar fashion. Then we have the layout manager. The layout manager is going to tell us how we're going to put the stuff on the screen. Some people call it a canvas. You could call it a window. I think Microsoft likes to call things canvases, though. But Java likes to call it a window, actually. So here's an example where we have a flow layout, and where in fact, I'm going to show you an example in a few minutes using Java source code that's going to be a flow. It's kind of very similar to the linear layout in the Android. We have a relative layout. We have all of the different layouts that exist on the Android platform exist in the Swing library. So it's all the same stuff over again. And nobody actually memorizes all the different layouts. You play around with it. You figure out some layouts that you like to work with a lot. And the differences between all the different layouts is how, by default, are the components going to, or what kind of capabilities and how are they going to appear by default on the screen. If it's a flow layout, which we don't actually have a flow, we call it a linear layout in Android, but the layout names may differ, but the selection choices are the same, or similar, I should say. This is just going to be word wrapped. So this is like the linear. It's a line, and then it goes, make the windows smaller, the buttons move around. So we'll see an example of that. All the components in the container are positioned by layout manager. Layout manager is the first component. So if you're creating an Android app and you're using with an XML, the first thing you do is put a layout out there. Everything is enclosed in a layout. So the same thing for Java GUI programs. So what you learned, if you've learned that, you just open up a new Java program, create a layout, put some stuff inside of the layout. Only thing is, if you do it with Eclipse, you're going to kind of do it the manual kind of way by writing the code. There's no, well, there's a plugin for it, but I don't like the plugins. There's a lot of Swing plugins, and there's a lot of third-party programs that allow you to take and drag and drop, kind of like the Android 8 SDK, which allows you to kind of work with that XML screen and kind of move things over easily. That one's okay because it's kind of lightweight. Some of the other ones, they add a bunch of extra code to your source code, put a bunch of stuff you don't need in there. and it makes it too complicated. And you'll see in a few minutes how easy it really is without that, as long as you know the hierarchy, what it is you're building. But we'll see that. So in the layout manager is used, the buttons in the above example follow the flow layout manager. So we pick a layout manager and we use it, which is the default actually. So we don't specify layout type, it's going to be a flow. So the default manager aligns the components horizontally until there's no more room, and it starts a new row. So that's what I call word wrapped, sort of. And after resizing the container, the layout manager reflows the components automatically, which is kind of nice actually, if you want that event or you want that kind of activity to occur. The default is to center the components on each one of the rows. So if you make the window small, it'll hopefully be centered. And you can also choose to align them to the left or to the right by going panel.set layout is new flow layout. But on your layout though, you're saying .left, which is saying left align everything, right align everything. There's other ones you can go on and use this tutorial here, or the Deedle and Deedle book actually is really nice in terms of being able to figure out which layouts. There's like maybe 3 or 4 of them or something. Personally, I use relative layouts because I use the relative layouts for everything because it's just easier. I don't want things to word wrap and flow. I want this to be over here, this to be over here, this to be here. I like to pick where I want things. So layout management problem here is using a panel. So you've got a panel that appears. Potential problem with the border layout, here's a border layout as an example, is that the button is stretched to fill the entire southern region of the frame. Well, a border layout might be okay on an Android phone, but on a Windows application, not necessarily going to be that good looking. So here's a button that's kind of stretched out because you used a border layout. If you add another component to the southern region, it's just going to displace the first button. So here we have more than one button. It actually looks a little bit better on the border layout because now we have 3 of them down here, and it's on the border on the bottom of the screen. So the solution is to use panels, and if we use panels, we can apply the right layout to the right section of the screen. This is equivalent to the Android XML interface where we put a layout inside of a layout, because Android doesn't have panels. All we have are layouts. In Java, we have panels, which is equivalent to a layout if you think about it, because you have a layout and you put something inside of a layout, you're nesting it, so it's really created a panel, right? If you're an HTML web developer, you call it a frame, or you call it a table, row, or column, entry. It's just a way of dividing out the screen. More like a frame analogy, I guess. So a panel acts as a container for the interface elements that can themselves be arranged inside a larger panel. So you can nest a panel inside of a panel. You can nest a layout inside of a layout if you want, actually. So to fix the problem here, if you only had one button and you wanted to kind of do it like that, you can do this. And what you're going to do is create a panel, add components to the panel, and then add the panel to the larger container, which is the layout. So what we've got here is a JPanel P. You're making an instance of this object JPanel. It's going to be equal to a new JPanel. And you're going to go p.add this button, p.add this button, p.add that button. And then take frame.add the panel to the border layout, but on the southern region. So instead of making it left, right, you're going to be southern. So it's down south, so it's on the bottom. Some supplemental reading. And these links actually still work, although they will take you automatically to the Oracle instead of the Sun site. Don't recommend the Oracle documentation, however, or the old Sun documentation, because it's really lengthy. That's why I mentioned the Deedle and Deedle book again. And for those of you who can't remember, let me refresh your memory on that book. There's like 9 editions of it out, 8 or 9 editions, and I have to go to the website anyway, so it's the Deedle, but we don't want Android, we just want Java. How to program in Java. The Deedle and Deedle Android book is also very excellent, actually. 6th edition, 7th edition, 9th edition, wow. Well, I just click on this one because I clicked on it before. This is the book I'm referring to, and the examples I'm going to show you in the next couple of minutes all come from this book. Actually, there are smaller examples of bigger examples that you'll find in this book. And so when you see the examples, you're going to go, oh, this is really cool. This is where you can find the examples I'm going to show you in the next few minutes. Deedle and Deedle. Best guy out there for Java. No, he doesn't pay me to say that. So. Oh, let me show you where those examples are that I'm going to show you in the next few minutes here, as soon as I show you the examples. So let's see. They're under, for those of you who saw me clicking real quickly here. If I go to bhacker.com, I go into the Object-Oriented Programming in Java course. I go into Course Materials. I go down to the bottom, and I look at the lecture examples. I'm going to show you 2 files today, or 3 files. I'm going to show you this one down here. It says Lecture 8 and 9 examples. We'll cover, that was Lecture 8, by the way, that I just showed you on the PowerPoint. Monday we'll do 9. We'll actually start on the next homework assignment on Monday. I'm going to show you button text. I probably should have zipped these all up, but they're all separated out. These are the text field, the button, the label list. All the individual Java programs I'm going to show you in a few minutes are listed here. So if you see something you like, look for it here. That's where you're going to find it. So let me bring up Eclipse. And I'm going to show you a couple things. My settings in Eclipse are kind of crude. I don't actually have a class path set. I don't have an environment variable set. So when I run it, some of the images that I put in the folder are going to show. So I'm going to exit to a command prompt and run it from the command prompt, because I want to show you that it works from the command prompt as well. So it's kind of twofold in terms of the reasoning there. So let's take a look here. I created a generic project. I called it Swing. And I dragged and dropped, and I'm assuming you guys know how to do this already. If anyone wants to see me do this from scratch, let me know. Otherwise, I'm going to assume we can create a Java project. And I downloaded the stuff. I think I removed it off the desktop. I did. But I downloaded that stuff, and I just dragged and dropped it into the folder. What you're not going to get in the folder are these 2 images, bug1 and bug2. But you can find any 2 images you want and use them. So PNG images or JPEG images, you just change the name of the image or name it this way and make sure they're PNG images. So the first one I want to show you is the button test. And I'm going to make this kind of big so you can see it in a few minutes here. Let me make this bigger. Zoom this a little bit here. Zoom in a little bit here. Alright, so this is the lecture again, but now using a source code example. So I'm going to go through it piece by piece to show you what it is that we're looking at. So this is the button test. And this one is using both AWT, and it's also using Swing. And we'll see the components in a few minutes. So by default, you're probably going to want to put both of them in. Only because you don't know which components you're probably going to end up with, and Eclipse will tell you if you start typing in something. The button here itself, I'm not going to. Actually, it's the container that's coming from AWT, I believe here, but because the J button's coming from Swing, so. But if I wasn't using J buttons, I wouldn't have to be using the Swing, actually. But these are your standard imports that you're going to use, and in the imports, we have well. The entire program is running from one Java class that I'm creating. So main's going to be inside of here. Everything's all in one file. So this is, you guys know object orientation already, but don't worry about it. Skip object orientation for this demonstration. Everything's all in one file. And the name of the object that we're creating is the name of the program that we're running. It's called button test. And it extends JFrame. JFrame comes from the Swing. And JFrame is going to be the window. It's a framed application, which means it's not a DOS console application, which is what's going on there. By default, when we don't extend from anything, we just create a GUI class that's not going to run from anything. It's just going to be a DOS input output, or Linux kernel. A terminal window. Okay, so. My data members as before, but this time instead of saying integer x or something, or I'm going to say private J button, and I'm creating two J buttons. One's called plain button, the other one's called fancy button. So these are two variables, instances of objects. Well, they're going to be. These are references to those objects, equivalent to saying string n or something. So this is the data members that are associated with this class. So to set up the GUI, I'm going to have a method called button test in here. And button test is going to go super, testing buttons. Super is setting the, excuse me, this is the constructor, by the way, is calling the super constructor. The super constructor is from JFrame. JFrame is the frame. So you know what I'm talking about. Let me just run this program so you can, I'll show you the before, excuse me, I'll show you the after so you can see this thing work. And then you know what I'm talking about, hopefully. And I'm going to go out to DOS to run it because my images aren't showing up. So what I've done is I've exited out I've gone to a terminal prompt. I've changed directory to workspace, which is the main directory where all my projects are being stored. And I changed directory to swing because my project was called swing. And in my project, I have two directories. I have bin and source, two subdirectories. And those are the same subdirectories, by the way, that you see out here, source. And this is the bin directory, or inside of here we're going to have the bin directory because we're going to have the compiled binary version of our class files. So I'm going to change directory to bin, and this is where I'm going to find all my .class files. So I'm going to zoom out so you can kind of see the effect of what happens, and I'll zoom in so you can see what's being shown on the screen. So this particular example is called button test, and so I'm going to say Java space button test. I can also run this, and I'll run this in a few minutes from Eclipse so you can see as well. The same thing's going to happen essentially. And here's what's going to happen. It's a GUI application, and lo and behold, I've got a GUI frame that shows up. And I can make the frame bigger. I didn't change any of the components on the frame. I didn't add any closed, but well, I've got this by default. It's inherited from frame. But you see where it says testing buttons? That's the window title, and the window title is set with the constructor when you make the frame, and so which is the default window. I can make this frame and I can put windows inside of. I can nest things inside of. But this is my main frame that I'm working with. Frame's got a title, and the title is what was set here. So testing buttons, and I called super because it's part of the J frame that I'm inheriting from. And in there I'm sending, well, run the constructor that sets the title. And what you do is you go online, you look up JFrame, and you see all the different methods, all the different constructors, all the different ways of using it. And you go, oh. But this is the most common, I should say. So on here, I'm getting the content pane, and I'm setting its layout. So I'm going to leave that running up in the background for a few minutes, and I'm going to show you the functionality as we implement it. So my button test class, my constructor is going to open up the window, call super to open up the frame, which is going to open up the window, set the title to testing buttons. And then I'm going to create a container. So I'm using container. Container is coming from AWT actually. If you go back to that PowerPoint and you look at the hierarchy, sometimes when I'm working in a room in which I can have a presentation board and a chalkboard or a marker board, I would write the hierarchy down there for you so you can kind of see it. Because you build the components in the same level. You have all levels of the hierarchy running, which is kind of interesting. So what I've done here is I've said container, could I call it anything I want? I could create a container object, and that's going to be equal to a new get content pane, which is the method to say get a content pane. I've got one that I'm going to use. I could use more than one container if I wanted to. But for this particular application, I'm only going to have one. And here's where the layout comes into place. So I'm going to go container.setLayout to equal to the flow layout. So I'm saying for this particular container that I have running, use a flow layout, and the flow is big. The flow layout says if I'm going to, if I make this window real small, now I have it word wrapping this way. If I make it bigger, it comes out this way. So I may not necessarily want that effect in my program, so I might use a different layout. But the flow layout is the one selected for this example. And which would be equivalent to the linear layout if you're doing this on an Android. Now I'm going to create some buttons. And so I've got a plain button, which is going to be equal to a new J button. And when I run the button, I'm going to put the title in there. It says plain button. And then I'm going to go container.add plain button. And plain button is going to be the plain button here. And where's the plain button come from? It came up from here. So there's a lot of people that don't like to declare the variables up here. Same thing with any other variable. I could come down here and say, you know, J button, which is J button. If I spelt it right, and I did not. This is a capital J. J button, but you know, then up here this would be a duplicate. So it's either way you want to do it. It's fine. Create the object reference and then create the new object and assign it to the object reference, or create the object reference and assign a new object instance to the object reference at the same time. So if you do it in this step, it's easy to see what the buttons are. You go up here and you go, oh, look, plain button and fancy button. You guys know you can do this on 2 separate lines as well, I hope. So, alright, so here we got plain button is equal to new J button, and give it a title plain button. So container, this is the container here, dot add. So this is kind of this is the Deedle and Deal style / the Barber style. When I create something, I like to add it to the container immediately. There's a lot of people that take a different philosophy to this. Create all the items, and then at the bottom of the program, add it all to the container. So it depends on how you think. I don't have to go, you know, create it, add it, create it, add it, create it, add it, create it, add it, create it, which, you know, I forget to add it if I don't create it and add it. But, you know, or I leave a button out or something. But you can create all everything and then add everything at the end, but you got to do both. So this is kind of like how I like to do the sets and the gets and sets. You know, this is kind of the same thinking. I'm just that's the way I think it. So, all right, so I got the 2 buttons here. So I've got, excuse me, my plain button. Now I'm going to create some icons. And the icons here I didn't put up here, which is kind of interesting. Again, it's another programming style kind of thing. These guys I'm going to use over the buttons. I'm going to use the stuff I'm going to put on the buttons. It's for decorative purposes. They're not necessarily data components, and they're not data members of my class that I'm going to use constantly. So down here I'm going to say icon bug1 is equal to new image icon, and this is where those images come into place. And where do you stick those images? Well, if you're in the Android class, there's a separate folder for it. It's called the resource folder. If you're in the regular Java class, we don't have a resource folder. So we just have a folder. And where's the folder? That's just the main source folder. So you could dump it all into one folder. You could make a subfolder here, and you could put it in a different folder. For right now, make your life simple. Stick it all in one folder. It makes it easier, because if you go out here and go out to the prompt here and you look for these guys here, the program's running. You can probably see it out here. Here's my bug1 and my bug2 PNG file located in the same folder. If your stuff doesn't appear, and we're going to see that when I run it in Eclipse in a few minutes, it means that your path's not set. If it doesn't run, your class path's not set. If your directory path of the project's not set correctly, which I don't think it is actually, it's not going to run. It's not going to find the images. Or you could be smart and you could preface the images, but then again, if you move the directory, you know, the directory changes. So anyway, long story short, you've got some options with the buttons, with images and loading in files. You can load in JPEG images, you can load in GIF images, PNG, anything that's compatible with regular old Windows or Coca development, I should say, any of the standard types. So we have icon bug number 1, we have icon bug number 2. They're both equal to 2 new images. I can put a space in here. I probably should put a space in here, actually. And I've made 2 instances of 2 new objects, bug 1 and bug 2. And this is the same thing. This is the same way we've been making instances of objects with students and people and stuff. It's the same thing. So now I'm going to go back to fancy button. Actually, I have to create fancy button. I haven't created it yet. Fancy button. So I could have created fancy button up here, but this is kind of like a sequential process. So fancy button here is going to be equal to a new J size button. J button is going to have fancy button, and it's going to have bug1, which is my image. So the constructor to create a button, you got to go look up the constructors. One of them, you just set the title, so the image in the title. You can set, I don't know what else you can set, background color, foreground color, text color, you name it. Look them up. Fancy button dot set rollover icon. Rollover. Another method to set the rollover icon. We're going to set, so when I roll my mouse over the button, we'll see that in a few minutes, it's going to go up to bug number 2, which is the second bug. And then I'm going to take the container dot add fancy button. So once I've taken the button, created the button, did everything I wanted to it, then I'm going to add it to the container. And the container is again up here. This is the same container I added this button to. I can create multiple containers, add things to different containers. They don't all have to go to the same container. The rollover activity is this here. My images are kind of big. If I roll my button over the fancy image, actually it's not too big now. When I made this smaller, the images were too big. Let's see. Oh, no, it still works. Oh well. That's because I had the screen big. If the screen were too small and the image was bigger, the image wouldn't fit correctly. But if I roll my mouse over, I see the bug change. Okay. I stole these actually out of an iPhone app, iPhone example, so those are where the bugs came from. Scary bugs in the iPhone class. Those are the scary bugs. Alright, so create an instance of an inner class button handler, okay, for use with the button events. Okay, so we got our buttons, we ran the constructors to put an image on a button, and one of the constructors only put a title. It's a plain button. So now what I'm going to do here is add a handler. So I'm going to go button handler space handler is equal to new button handler. Now handler. Well, the handler is going to be used to capture the event of the button click, the long click, the short click, the double click, all of the different types of events that could be occur through the handler. We actually have handlers in Android. It means the same thing and it works the same way. A handler is a handler. It does nothing more than handle the event. We add and we change things about the handler to customize the listening behavior. So fancy button dot add action listener, use the handler for it. So we're using the handler instance object. It's just nothing more than a worker bee object that goes out and handles stuff for us, which is why it's called a handler. We can get away in a lot of instances. Actually, there's ways of doing this without the handler, and I have another example that doesn't use a handler. And there's Android examples that don't use handlers as well. So, but it's just one way of doing it. In fact, this is simpler. It's fewer lines of code, actually. But plain button.add listener handler. So we're adding it to the same handler. So when we press the buttons, both buttons are going to have the same events. That could be different depending upon how we want to catch and handle the particular event when it occurs. So we're setting the size here. This is the size of the initial window that shows up. If you notice, I made the window bigger. So this is just the initial size to set the size. You can fix the size and turn resizable off. It's another method that you can put on the window, on the frame, on the J-frame, to basically forget about. And these are instance variables, so instant methods for that particular instance. So I can set size, I could set visibility, and here's to set visibility to true, set resizable to false if I didn't want them changing the size of that window. Have a flow layout, it's going to get ruined if you make the window bigger or something. And here's main, and main's on the bottom here. So executing the application, and as I mentioned before, it's not your best example in terms of object orientation, but it works. So it's all in one file. So main is going to have a button test application is equal to new button test, and I just called it application. I can call it button test program or whatever. Made a new instance of the object. A new instance of the object here, and I'll put this all in one line so you can kind of see this a little bit better. There we go. Application, which is button test object, set default close operation to exit on close. So when the window closes, it's going to shut down. It's going to exit the program. So when I close this window, my program is over with. You can set different types of things because button test the instance of this object that I created application is of button test. Data type, which is of frame, JFrame. So on the frame I can run anything. So I can basically set it so that there's no open and close button. I can take those buttons off. Let me tell you. I can remove this stuff up here, make it a dialog box or something if I had the program, and then put a close in here. I don't have a close button here, so I set the behavior so when I hit this it's going to close. I can remove, I can put custom things anywhere I want to kind of control the behavior of the window of the frame. So just keep that in mind. You don't have to use the default behavior. Okay, so we have in the main program, we're going to have the button handler that implements action listener. So the button handler, we're going to put on the buttons to say, listen for clicks, or listen for activity to be performed. And the action performed is going to be for the action event that occurs. So this is to handle a button event when it occurs. Notice I'm doing this in main. So if I took this out, it would still display the window. It would still have the handler associated with it, but it wouldn't be actually doing anything when I clicked on it until I set the behavior to do something. Where do you put the functionality? It's up to you. Don't have to put it in main. I could actually stick this in the class itself, which is more common. It's more common to see it in the instance object. Put the button, put the handler in there, put the button listener in there. Put everything in there and just make an instance of the object, and this would be one line of code essentially, which is the other way of doing it. So you have some flexibility, so the components can move around. So the inner class of the button here is another class called a button handler class. This, believe it or not, is an example of another class. So I have a class inside of a class, or an object inside of the object. We could stick this object inside of that object. We could stick it inside of this object. If you think about it, this object here is inside of this object as well. So it's all nested. So what do we have here? We have the button handler, and this is going to be the action performed event. So handle the button event, action performed, which is going to call to the super method for JFrame. On the action event, it's going to say JOption pane show message. So show message dialog. Message dialog is a built-in dialog box. If you've ever done any Windows programming, you see those dialog boxes for MFC. You've got alert boxes for HTML code and JavaScript. Another example of a automatically created box that opens up. So JOption.pane, and it's coming from option pane, which is another component actually. And we're running this component. It's kind of a crude way of doing it. I could have made a reference to the object and then taken the object and made a new instance of the object, but instead I'm just calling it it's a static method actually, from JOption pane dot show message dialog. The message dialog is as you pressed event.get action command, which is an automatic method on the event, and the event's coming in through here. So on whatever activity happened from the listener, which is automatically implemented from action, because we implement action listener. So this is an interface because it implements. So anytime you say implement, you know it's an interface. And in the interface you have to implement required methods that are associated with it. And so we have to implement action performed. So if we left this out, if I deleted this and I just put in here, if I did this, let's see, let me cut it and paste it so I can put it back in. Eclipse should give me an error message, and I click over here, it says add unimplemented method. And there I go, okay. Or make it abstract. There it is. There's where it comes from, essentially. So you can use Eclipse to tell you which methods you have to implement from the interface, which is kind of the cheat sheet way of doing it. Or you can remember that and put it in. Or you can let it do all of the fancy work for you and you just fill the body in if you want to do it that way. And that's pretty much all the program is, essentially. It's a main program that has an action listener. So let's take a look at the action listener. The action listener is going to pull up a dialog box. So if I click on, this is the mouse over, if I click on the plain button, I get this dialog box. Message is the title, which is the title well, the default title it looks like. You pressed, and then the event. So it says you pressed plain button, which is going to be essentially the label of the button that was sent by the event to say, on OK, do this. On cancel, do that. So you could capture the event if you wanted to. Here we didn't capture the event. We just took it and we put up a little dialog box and said, you know, you press this one. If I press on this one, let's say you pressed fancy button. That's great. So, but normally you'd have stuff on here. It says, you know, if you press this button here, you know, it's going to open up this menu, or it's going to open up this other window. It's going to, you know, go to file print, or, you know, that's how you're going to navigate the program. That's how you're going to create the interface for the program, essentially. So you can see it looks pretty sophisticated. If you run this on your Windows program, on your Windows box, you'll see a window, or will you see this? Depends on what you're using. And this here is using JFrame. So you're going to see a JFrame is from the Swing component. So you're going to see multi-platform supports. So you're going to see a window that looks like Windows. So actually, an interesting question if someone should run it. I'm pretty sure you're going to see a window that looks like window. On some of the other ones, you might get an error message because the AWT component is platform dependent. And some of the Swing stuff, JFrame is platform dependent actually. So JFrame is going to show you a window that looks like Windows, come to think of it. What it's going to look like, what is going to end up happening is when you start developing GUI components, you're going to need to test it on all the different platforms because you may not necessarily know exactly what it's going to look like when you first run it. I mean, it looks fine on my computer. Here, I'm running on yours. I don't know, this one's going to work just fine as long as I include the images, but some other stuff might look different depending upon the AWT because some of it's platform independent, some of it's platform dependent, which means it's going to look different. It's kind of like the same problem you have as a web developer when you write HTML code and you run it in Firefox and you run it in Internet Explorer and you run it in Chrome. It's going to look different. And not only that, it's going to act different too. So it's kind of interesting. That's one of the things you'll get when you start using GUI components. If I run this from Eclipse, I'm going to run into a problem, and you're going to notice this problem as well when you start working with GUI components, is that it's looking for bug 1 and bug 2, and I dragged and dropped them and I put them in here, but I didn't set my project up correctly. I sort of did this on purpose to kind of show you what was going to happen. So most people would do this, and they go, button test, okay, run as Java application. It is a Java application, just like any other Java application, but instead of the stuff coming down here on the console, it's going to show up here. And I'm going to go, well, that doesn't look like a fancy button. What's wrong? It doesn't work. It's because my button, this isn't working either. But you know the code's correct, you just saw it worked a few minutes ago. My project properties aren't set correctly. In fact, I just basically changed it around so it's looking at the workspace directory instead of the Swing directory. I mean, this is the Swing directory of the project that I created. So it's looking in the wrong directory, so it's not finding my images correctly. So when this happens to you, if you're using Eclipse, the first thing that I would do as a troubleshooter is go out to DOS, or go out to the terminal prompt, run it like I just did a few minutes ago from the terminal prompt. Make sure you have all the components in the same directory if you've got it set that way. Then run it. Because it's deceiving. There's no error message, there's nothing. It just functionality doesn't work and the buttons don't show correctly. You go, oh, well, there's a problem, and then you spend hours trying to troubleshoot the code when there is no problem. It's just the project properties aren't set correctly here. And when you take these files and you deploy your application, you can jar it up, you can do anything you want with it. We'll get to that probably next week, actually. To move your application. Well, you're working with the class files, that's your program. You're no longer testing in Eclipse anymore, so you can deal with it in Eclipse if you want to, or you can just not bother and just run it out in the real world and see what happens to it out there. Any questions on the button example? Let's go on to something else. Let's go on to a label test. And the easy part now is I don't have to skip half this stuff because it's all the same. What do we got for the label test? Actually, let me show you the label test. This is called label test. Label test. I don't know what it's got on there, so I'm just going to run it out here because I know my path's not set correctly. Java space label test. What is label test going to do? Lo and behold, I got a J-frame, testing J-label. And, oh, there we go. You couldn't see it because I had it all. Actually, let me go this way here. Label with text, label with icon and text and button. So it's the same bug as we had before. Let's do it this way. That's better. So you can kind of see what's going on here. So basically, I'm creating a label and I'm putting a button on a label, which you can do. Or you can, it's just kind of different, I guess. It's a label. But how are you going to get stuff on the screen? So you can put an image box out there. In fact, you can just put the image out there instead of putting the image in a button. You could just put the image on the canvas if you wanted to. Or in a label, you can just put the image out there. So let's take a look at this. Nice code here. It's pretty easy, actually. And now this is the fun part because you already know all this. So I just went through it a few minutes ago. It's the same. It's just a different component. Making an instance of label 1, label 2, and label 3. There's 3 labels on there, but because of the flow, it actually looks like 2 because you see the 2 bugs, but there's one of those labels doesn't have a bug associated with it. So if you make the windows smaller, it actually looks like 3 labels. And this kind of demonstrates one of the problems with the flow layout. So setting up the GUI, here we go. We have, the name of the class is called label test. And if you have your mouse over this warning, you're going to get the warning on everything. You can add a suppression for the warning for the serial, or you cannot deal with it. You don't really have to. This is sort of, again, one of the problems with Eclipse is that you don't need to make the thing serial. You don't need, okay, so what does it mean? How many instances of this object are going to be created? What environment are you going to run it in? You're never going to get that error message in Android because Android actually sets it for you automatically. So it doesn't set any serializable, and I haven't talked about that in this class yet, but it's coming up in the lecture. But lo and behold, this is an example of something that you're going to see that you may not necessarily, oh, this isn't used, huh? Take out that imports. Let's see what happens. I didn't use the event on here. Oh, there's no events, so I just, well, what happens with this example is you just cut and paste and you include the packages on the top. So I had events up here, but there's no events on here. There's no activity where nothing occurs when you click on anything. Okay, so another example of a warning that's kind of senseless for this particular program, but I don't know. People worry about warnings. People worry about yellow stuff, red stuff. So don't worry about it. It doesn't apply to you. So J-label. Label 1, label 2, label 3. Another component. Instead of J-button, it's J-label. And lo and behold, here's our testing J-label. We're sending it to frame because we're doing the same thing again. We're extending from frame. All your GUI applications are going to look like this. You're going to extend from frame. You're going to have a label for the frame, for the window. You're going to essentially run through the same format. You get the content page. Oh, you get container. That looks familiar. You get content pane. Assign it to container. This is the container. Container is the content pane. Container.set layout to flow layout. We're going to change the layouts around. In fact, what you can do is download the examples here, change the layouts and see the effects. Change it to border layout if you want. Here's the J-label. Same as before, J-label 1 is equal to new J-label, label with text. And then here's a set of tooltip text. So if I put my mouse over, I should have a I didn't actually do that. This is label 1. So set the tool text, it's like, oh, that looks pretty fancy. And this is, if I take this flow layout and make it a little narrower. There we go. This is label. This is label with text and icon, label with text and button. Label 3 is actually small. Okay, so there's some errors in here. Not errors, but it's not consistent in terms of my tool text. So you can be context sensitive help if you wanted to. You can put your mouse over here. Hey, this is a bug. Well, this is actually label 2. So. That's the set tooltip text. There's other things you can set on the label. You can, when you put the text, when you put the mouse over the label, you can change the color of the text, which is kind of inconsistent with behavior. In fact, you can do a lot with GUI components. The only problem is you don't want to confuse the user. Get too carried away and start confusing. Like, that's not a button, that's a label, but I have to click on the label to get this to work. But I don't click on buttons. Is that a button? Why would I have a button? It's an image. So here we have our JLabel constructor with a string, an icon, and alignment arguments to set the alignment. So one of them has the alignment to the left, the other one has the alignment on the bottom. So it's setting the different alignment. So icon bug, setting a new instance of an icon, an image object called bug is going to be equal to new image. This is the same as before, actually. Label 2 is equal to new JLabel, label with text and icon, bug. Swing constants, dot left. Swing constants, well, it's a swing component. You're actually running from the swing component level a static member that's going to set the context. So you're actually running it from all components. So you're gonna find it interesting actually when you get your reference book, if you get one, or you go on the internet, you find out, well, what are all the properties I can set for a particular label? They're all going to use swing constants because it's all the labels, the buttons, everything's going to essentially use the same set of methods. Set it to set the context to the left, set it to the right, set it to the center. So it's pretty consistent across the board. So we want you to remember, once you try what you did on something else, and lo and behold, it works, hopefully. So label 2 is set the tool text to label 2. And then we're going to add, move down a box here, it looks like. You're going to add the component, add label 2 to the container. And then we have label 3. Label 3 is going to basically set the text. And then we have what? Set icon. We set an icon for a label. It's one of the methods. So, okay, set the icon to bug. Alright. Set horizontal text positioning. Set vertical text positioning. And then here we go again, as I was saying before, we have swing constant that we're going to set to center, to butt. Because for the swing component, we have constant variables set at a class level of the component that says left, this is right, this is top, this is bottom. So that's why we're using this sort of like it's like a variable. Instead of saying center, it's not going to, what do you mean by center? It has to be swing constant center. Just so you can preference where it came from. Set the tooltip, add it, set the screen size, set it visible. What happens if this is false? It's not going to run. It's not going to show, actually. Let's run it from here. This is not an applet, by the way. I had to make it smaller. Java application. Select type. Oh, which one am I going to run? I'm going to run label test. Yeah. I click the project. I'm so used to Android clicking the project. It's running. It's running. Nothing's going on. Because it's false. So you want to make sure that you're setting it visible to true. If you leave the line out, it's not going to show. You set it to false. But why do we want that? Well, because what if we want when you click on a button, it sets it to true, and it opens it up. So now you see it. And then when it's like create dialogues, actually, by the way. So when you click on a button, the button in the handler for the button, it says set visible. Actually, it'll set label 3 dot set visible to true, because the set visible here is on the panel. You can actually do visible on a button, visible on a label, visible on a text field. So you can set visibility on and off, and then when the user clicks around, you can selectively show them stuff. That's what that's for. But unfortunately, there's no default for true. It's false. So you have to set it to go, okay, turn it on, which is weird. Here's main, and you see main is like, I don't have an action listener, so I didn't put it on here, but label, label tests application is equal to new label test. Make a new instance of this here. And this is kind of sloppy. I put it inside of this program here. Set default close operation. I can leave it off. If I leave this off, the application won't close, actually. It'll kill it. So we'll just leave it alone because I don't want to mess up my computer. But this is how you're going to close it, because I don't have a close button on the window. If you don't want them to close the window with that button, and you want them to hit the close button and make a true dialog, actually you can get rid of the frame too. You can get rid of the border, make it a borderless, buttonless dialog box, just a window that shows up. okay, or cancel, or continue, or go back, or you can basically change the operations. And you know how to do that already. You just put buttons on there, actually. And you set button handlers. So you got labels. Let me kill this guy. So nothing happens when I click on it because I don't have anything here, and that's going to close. So because I didn't rerun it. So questions on the label test. Nope. Now what do we got here? Text field test. Now this one I can go really fast through. Because as you might imagine, it's going to load up a text field. What's this one going to do? Test. Text field test. Field test. Where is it? Here it is. Way up here. This is interesting because we have different types of text fields, and this is showing you different properties that can be set on text fields. Text fields with words in it, text fields that are empty, uneditable text fields. I can't edit you. That's irritating, by the way. And then text fields that look like passwords. They're encrypted. It's basically a password option. This is very similar to Visual Basic, actually. It just reminds me of that. However, if you do this to your users, you're going to irritate your users. So there's a lot of people that use Java to go. We haven't done this yet, but you can actually query a database and take the result set that comes back from the database and fill it, attach it to a bunch of GUI items on the screen, and you use all text fields for it. And then you have something like this, and it's a read-only value, and you can't edit it. And then it's irritating because someone tries to edit it. So instead, just make it into a label instead. So. Unfortunately, when you take programming classes, you don't really learn good UI design. So, usually most of the time. Instead, you get one of those books, say how to create something for UI design. Lo and behold, same includes as before. Lo and behold, same extension as before. Lo and behold, same concept as before. Except for we got two different things going on here. We got the text field, and then we have this text. We have this password field, which is inherited from text field. Has the same properties as text field, but it's an extended class. It's higher up in the hierarchy. What this does is it gives you that little, the dots or the, dots. You can actually change it. You can override the hierarchy, put asterisks in there, lines in there, anything you want, actually. So you set up the GUI. Lo and behold, we're going to run the constructor for JFrame, and we're going to say set the title, and we're going to set it to this. Lo and behold, we're going to set the container. We're going to set the flow layout for the container. Then we're going to construct the text field with the default sizing. Now, 10 is the default. So, text field, new text field. Instead of giving the text field like a label, we're giving it a size. And then we're going to say add text field 1 to the container. And then now we have 2 where it says put this in here. The size doesn't, actually there's one where you can, here it is here actually, we can specify the size. So the constructor for the JText field, we've got one that sets the label, the size, the label and the size, or none actually, and we have the default size. You can just leave this out and actually just say text field if you wanted to. But most people want it to create something of particular length, so that's right. So here's constructor number 1, constructor number 2, here's constructor number 3 that's adding in both the size and there, and it's also constructing a visible one with the default text, and we are setting editable to false. And lo and behold, we can. Actually, we can set visibility to false, and the thing would be gone too. Probably better than setting editable to false, but then you wouldn't see how to make it not editable. Container.add text field 3, same as before. Construct a text field with default text here of JPassword field. Hidden text. Add it. It's of this type, which is inherited from this type, so it's automatically going to put it in the hidden characters, the dots. Register event handlers. Oh, I have event handlers on here. Didn't even realize that. Text field handler. Instead of the button handler, we have a text field handler. Same functionality as before, actually. Well, we're registering the action listener on the handler in the class itself. And we have the event behavior listed in main. which is kind of common to see actually, because each program that uses a GUI component that you've got for this particular window, you might want to have different things happen on different events. So you put the event behavior in main, makes it more customizable. It's not fixed completely in the class. So only stuff in that belongs in the class implementation is going to be stuff that's going to be reused every time you use that class. Other stuff, handlers, there's a controversy. You can put it in the class. You can put it in main, actually. So it's very common to see it there. So we have text field 1 dot add action listener handler. We're actually just doing the same thing over and over again. And you see it's the same concept here, because this is an inherited, password field is inherited from text field. So it works the same way as a text field. Set the size, set the visibility. And then now we have a handler that actually does something down here on the action performed. So we're making a new instance of the object. We're setting the default closure for JFrame to exit on close, so the window will close when we hit the exit, the red button. And then now we have the inner class that we're creating. The text file handler is the name of it. It implements action listener, same as before, same as the button actually. And we have action performed, same as the button, with the event that's being passed to it. This, you don't have to actually pass this. When the user clicks on something, it happens automatically through the listener behavior. So a lot of this is automatic. So we have a blank string here, string, and the user presses enter in the JText field. And what is the event going to do? It's going to take this text number 1, it's going to event.get action command, and it's just going to get it. It's just actually not really going to do anything with it. It's just going to take the string. Else, if they clicked on the second button, it's going to get the second button text. If they clicked enter on the third button, it's going to take the third button text. And then it's going to enter, what's it going to do? It's going to populate one of the, it's going to populate something here. Let's see what this thing does actually. I have forgotten. I believe it's going to take the text that you write in one of the buttons, excuse me, in one of the, that was running. Yes. There it is, a dialog box, testing, and I don't know, something, and I believe it's on here too. Actually, the active action listener I believe is on everything. Password. I actually put password in there because I wrote password. Put class in there, so it puts class up there. This is not going to do anything actually. An editable text. But this is on the event of actually pressing the enter key. There's other events you can register. Other events would be if the text changed. I'll let you modify to do that. Actually, you just have to find the right method actually. And like this text here can be put over here. And what are we doing? We're getting the property of get text and set text. Get password here, and we're putting it into the appropriate boxes. So string text2 from, and this is on text2, so the user presses enter on the text2, get the source, event.get source text2, get action command. Text3 is going to get action command, and the user presses it on the password field. It's going to do the same thing as string password field. If you do a new string, password field.get password. So it's getting the action or getting the password in a particular component. So. And then it's doing nothing more than taking the string that it got, and on the J option panel, which is the same dialog as we did before. Null, we didn't set a title for it, but we could set a title for it. This is the title field we just set to null. So if you don't basically want to set a title, just put null in there, and then the string. And the string is essentially the text that's in each one of the different options. So you see it's a lot of functionality, a lot of behavior for a very small code actually. Very small. So why install a third-party GUI editor? And when you have more control over it this way, actually, you get some pretty good functionality. Okay, so the last example for today is going to be the text editor GUI, and this is kind of the nice example because it's going to show you a lot of functionality. For very little effort. Let me just run it so you can see what it looks like. Whoops. and Control C. I don't know. I thought I closed that actually. This is text editor. It's broken out actually into two separate classes. Okay, hold on one second. Let me make sure I've got the components here. There's text field test, text editor GUI. How about that one? Text editor GUI. Here it is. Wow, lots of functionality. Ooh, very sophisticated looking. Wow. It's actually a very small program. It's using a built-in component. We got copy, paste. We got all these things. You know, this is a test. We can copy it. We can paste it. We can select all. We can clear it. We can even show the contents of bhacker.com. Let's see if I do have internet access. We can even go out to the internet and show the contents of this web page. It's not going to be, it's a text. It's not going to be an HTML format. We can actually change the property though and make it HTML if we wanted to really easily. Lots of functionality. Very little effort actually. Let me show you what this program is made out of. There are two files that go with this program, and this is the one that's in the 8.9. It's in the zipped file because there's two that go together. And so instead of listing them individually, I put them together. But you just put them in the same project, compile them, and they'll create all the subclasses that you need. So we have get URL. The URL get is nothing more than that little button that says www on it. And I put the URL in there, and it's showing you networking stuff. I'm going to hold off on this because this is actually next week's. This is, well, actually, I'll just show it to you. We looked at string. Did we look at strings yet? I can't remember if we looked at string now because it's next week. Alright, so this is creating a new string builder. String, it's a new class that's subclass from string, actually. We have string buffer, string reader. Here's buffered reader. It depends on what we're going to do with the I/O that we get, whether or not we're going to buffer it, whether or not we're going to use it as a label components, we're going to parse it. I have a separate lecture on strings, actually, I'm going to give to you. Probably next Monday, actually. But lo and behold, we're doing a URL connection. It's built-in functionality. Essentially, it says, you know, go out and create a URL. You can create a web browser in like 3 lines of code, actually, by creating one of these objects and attaching it to an HTML formatted, rich formatted text box, essentially. But here we're going to take from the URL, and the URL is essentially going to be given to us from that text line. So we're going to do a try. We're going to create a URL connection, and I'll go over this example again, so don't worry if you don't understand the networking part. Connection.getInputStream is the input stream from the connection object, which is going to go into the buffer reader, and the buffer reader is going to be the reader, and the reader is going to be basically looking at that URL from the URL connection object, taking whatever it gets from the reader and the buffer and then showing it out on the screen, which is the contents of the HTML page, essentially. You know, when you do an HTTP request to a website, you're getting text that comes back, and the text is being parsed and put into your browser window. If you don't know that, that's what's happening. Same thing's happening here. So while the reader is ready, append the input, put a line return at the end. So this is the first line, second line, third line. So we go through it. And then reader close the buffer, and basically destroy it, clean it up. And then we have, you should know this part, the try and to catch. We did this last time. So we're doing exception handling here. Well, we didn't throw any exceptions, which is kind of weird. We don't have to. We don't have to throw exceptions. We can just do a try and a catch. And on a catch, if we have a malformed URL exception, then print out malformed URL to the string. So if I come out here and I go, you know, something like this, I left out the .com on here. This is, oh, IO error. Oh, that's nice because I can't go to it. Let's go like this. That's not a URL. Malformed URL. So, this other one down here is going to say, well, if you can't get to it, you got an IO error. So I had the HTTP in there, so I knew it was a URL. So on this particular case, the URL get test is the name of our object that we're creating of this class. And again, the class and the main are part of the same. And this is a separate program that's being run. It's being run in the event of clicking that www button. So this is your common kind of format for how you're going to develop GUI programs. You're going to have multiple classes that are running from events that occur from people clicking buttons and stuff like that. So here we have the object is going to be called test. It's going to be equal to new get URL. The buffer reader writer is going to be equal to a new writer. So it's the reader and the writer set that you haven't heard about yet from the stream library that we're going to be introduced on Monday. So don't worry about that. But it actually puts it into a temp file called labcast.xml. Don't worry about this yet. Anyway, long story short, it's hard set actually because I put the writer test.setSite to bhacker.com in this example. So, but it does read it does take the input and do error checking on the input. So, but anyway, that's basic functionality that I'll go over in more detail because I haven't explained to you the string stuff yet. But that's coming up. But let's take a look at the GUI part, which is the focus of today's lecture, and you'll see. Oh, you was like, how can she cover the entire program in like 5 minutes or less? This is how. You already know all this stuff. We have a little I/O going on. We're using Swing JFileChooser. So JFileChooser is actually going to open and close and save stuff for us. Which, did I even put that in here? Let's see. Right up here. File, open. And you're like, whoa, that's really good. That's really good functionality, right? I don't think, this is not a text file. So it's going to show really weird stuff on the screen. This is the file chooser instance of the file chooser option, actually. And all this functionality is given for us automatically by creating instances of objects or built-in components that are part of the Swing library. The Swing library gives us the file choosing, the saving, the opening, the closing, everything associated with files. Excuse me, everything associated with the GUI that works with the files. And then we have the file, so we can save a file, open a file, which is part of another library. So here we're going to call this class now the text editor GUI, and I did this on purpose. Instead of extending JFrame, I put Java Swing in here because I didn't put it up here. So mostly you'll see it import Java x.swing. Like what we saw in the last couple of examples, or you could stick it here if you don't want to put it in the imports. We're only using it once, so it doesn't really matter actually. Actually, we're using it multiple times down here as well, so it probably should have been put in as an import because it saves us typing. So we are creating a new variable called file name, which is a file data type because it's a file name. It's going to be equal to no name by default. So if it's no name, we can do some error checking on it. Then we're going to create a new form, and we're going to call it text editor GUI. And so text editor GUI is initialize components. Text editor GUI is a subcomponent of Frame, which is kind of like your built-in dialog boxes, actually, which we haven't seen yet. This is only the first part of the Swing lecture, by the way. I have more stuff on Monday. Because we have to show you how to do a notepad program. But you probably have some good ideas of how we're going to do it, actually, at this point. Init components are these components here. It's just nothing more than creating a function, or method, I should say, and running the method inside of text editor GUI, which is the constructor. So the constructor is going to initialize the components. But instead of putting all this stuff in the constructor, we just kept the constructor kind of small. And we just said, put all this stuff in this other method and run the method first. This is the first line. It's the only line. We're not setting a title or anything for the screen. Actually, we're just setting this stuff in here. What is this stuff? We have the copy button, the scroll button, the edit pane. Wait. Cut button, paste button. There's a lot of GUI components on that screen. Here they are right here. I'm not going to go through all of them because they're all done the same way. We've seen them already. Was the button, the label, and the text field. In fact, all the items we've gone through so far are all the items on this GUI. So the set default closer option, that should look familiar at this point. So when you press the button to close the window will close. Set the title. This is interesting. So the set the title and set the name. We didn't call it from the constructor of the frame. Rather, we said on the item itself, set it. So we can set it. It's just the same way as when you call a constructor on any other object that you can create. You can do it when you create the object, or you can do it later. If you do it later, what's it matter? You just run a method. So you can do it both ways if you want. It doesn't really matter. Copy a button, set the text to copy. You can actually change the text of the button, so if you copied something, the button would change the text or something, you know. I mean, excuse me, paste or something. Copy button here and put an action listener on it. So you add an action listener, and here again, because I didn't import, this is why you want to import the, otherwise on each one of these components you have to preface where this particular what package it came out of, you know, rather than just importing the entire package. See on the action performed, the same as before, but now we're going to call it EVT instead of event. Same thing. Copy button, action performed event, run it. Run this method when the event occurs. The J scroll is the horizontal scroll. So the paste button, the select all button, the clear button. All these buttons are pretty much having an action listener on them. Taking the action listener and running the clear button action performed. The select all action button performed. And it's broken out. This is another kind of best practices kind of showing you just the same ways we took all this complicated stuff and we put it into one method and we called the method from the constructor. On each one of the action performs, we're just going to keep these small and put all the function in a method, and we're going to call the method on the action performed. So we don't have to clutter the code. It just makes it a little bit more readable, actually. So on this cut action button, paste action button, select all action button, all these behaviors that are going to occur on all these different GUI components. Anyway, if one of the components goes wrong, you go up here and go, what's going on? Oh, it's calling the load menu action performed. Oh, okay. So that's all of the functionality. Cut menu. Oops, went too far. So let's see. Save menu. So now I'm going to take, and I'm going to say JMenu1 to add the save. Say, oh, the J menu. Where's my J menu? Did I skip my J menu? I created an instance of JMenu1. Whoops, JMenu1 set title. Probably did it before. Here it is. Nope. Edit pane, J scroll pane. Here's my JMenu2, JMenu1. The menu that shows up for the two menu drop-down menus that appear here. These are J menus. We can set the options that show up on the J menu. So we created two J menus, and we're going to add the J menus to the code. And the J menus here that I skipped over. Whoops. So there we go. Or here JMenu1, or JMenu2, JMenu1, it showed up here. And then down here I'm setting the titles of the J menus. So the J menus, I should have put this all in one spot actually. J menu set text to number 1, it says file menu. I think the other one says save or option or something. I don't know what JMenu2 says. JMenu2 says edit on it. And then I'm saying JMenu1 add the save as menu, which is the component that's going to be save as menu, set text to save as. So I create menus, I add them to the menus, or menu items, and I add them to the menu by using the add. Same actual format as you would take and create components and add them to the container. It's the same concept, but you create a menu, and you create items for the menu, and then you add the items to the menu. So you can switch the menus around if you want to. They're not like hard set, like these items only belong to this menu, but you add them when you need them. And the load menu, I can set the accelerator here to load the Java I/O input event so that it can actually deal with the concept of opening, closing, saving, all of the different things that are associated with the file. I actually have an entire lecture on file I/O that's coming on Monday. So I'm not going to go through all of the details of the file, but what I want to do is kind of show you the components from a GUI perspective so you can see how the pieces fit together. And then we'll revisit this because we need this actually for the Notepad program. So I'll revisit this example again on Monday after I go through some more PowerPoints. But long story short, you can see the components in the source code. Nothing more than components that are grouped together. we have a group layout here instead of a flow layout. So we can put these into groups so we can have all the buttons on the top, all of the URL and the text line underneath it. And then the bottom group is the text box that's showing the output, stuff like that. So we can set the horizontal group here on the layout. For the layout to create a parallel group, horizontal group, different types of groups. You can set the preferences on the groups. And then down here on the bottom, we've got all of the things grouped together for the actions. And these are all the methods that are being called from all of the options that we set for all of the different buttons on the handlers. So we set a listener, then we take the listener when the action occurs, we run one of these methods down here. One of these methods down here is going to be the cut button action performed, paste button action performed, blah, 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 blah. We could have very easily stuck this code up there instead of calling these methods. But it would definitely require a little bit more code grouping instead of separating it out this way. So this is easier because then you can see, well, what's happening on the paste. You know, it's doing this paste. Oh, it's this edit paste is being called. Anyway, long story short, we have a dialog, a show open dialog that opens a file, which is a complete dialog that's built into the framework. And it's using a file chooser. So Monday's topic is going to be about file I/O, file choosers, strings, because when we take a file, we open it up, we read it, and we have to store it somehow. So we have readers and writers, buffers, and we have buffered and unbuffered I/O. We have file chooser. We have all of the different functionality that goes along with that. This is what you're going to use when you implement the next programming assignment. So what I'm going to do on Monday is revisit this as soon as I go over some more PowerPoint to show you file chooser and to show you the string stuff, buffers and the readers. And then we'll start building a notepad program, which is actually simpler than this. Fewer lines of code. This has got a lot of buttons on it. Your notepad's not going to have as many. Your notepad's going to have like 2 drop-down menus. Menus are easy, actually. Menus are trivial. So I'll talk about menuing as well. So this is part 1 of a 2-part swing kind of lecture. Might actually turn into 3 parts. I don't know yet. So. All right. So I believe we're on time. I don't have a watch with me, but oh, we're good. We're good. We're over time. Okay. Sorry about that. That's enough for today. I will see you next time. Monday for more swing. I would highly recommend actually downloading and playing around with these examples. I don't know if I hit the text editor yet, but you could play around the button test and the label test and the text field text. And if you're interested in learning it, and move it around, play around with the layouts, check it all out, and then it'll kind of get you a little bit of exposure to the concepts. And then we'll build a notepad on Monday. Okay, thanks. Thanks for listening. See you next time.